Okay, this is lecture number 8. Last lecture we have found out equation of plane in the normal form, and then we have found out equation of plane passing through a given point and coaxial with given two planes. Now today we will find out if two planes are given to you, Rn1, r dot n1 is equal to q1 and r dot n2 is equal to q2, then what should be the angle between these two planes? Now this n1 vector is vector which is perpendicular to this plane. That is what we have understood last lecture. And suppose there is one more plane which is this plane, then this is going to be n2 and this is n1. If this is first plane, this is second plane, and therefore the angle between the planes is going to be, suppose say now in one view I am drawing, this is the plane and this is the plane p1 and p2, then this is going to be vector n1 and this is going to be vector n2, and therefore angle between the planes is going to be angle between the normal vectors. Therefore the angle between the planes is going to be cos theta, which is equal to n1 dot n2 upon absolute value of n1 into absolute value of n2. It is the same formula for theta, and you can express theta as cos inverse of this. That will be the angle between the two planes. Angle between, of course it will be either acute or obtuse, because angle between two lines is always ambiguity. Unless and until they are perpendicular, you have to report acute or obtuse depending upon, but then any one of them is correct. Both of them are correct actually. Okay, then we come to angle between line and plane. Suppose here you have been given a line r is equal to a plus tb. So b is a direction vector and the line is passing through point A, and the plane is r dot n is equal to q, where n is a perpendicular vector. So the situation geometrically here is, you have a plane and you have a perpendicular vector which is n bar, and there is a line which is passing through A, and of course this line unless this b, vector b, is parallel to this plane, this line will intersect. And therefore let us take a case where the line is intersecting. So this is going to be your vector b in this direction, and the line will intersect the plane and will pass through. So basically we are interested in finding out what is this angle that line is making. So the line is making, actually there is little ambiguity in what is the, because we have not taken the pure geometry three-dimensional lectures. Now this is what is the position in which you are supposed to measure the angle between the line and this plane. Okay, but if you measure it, I mean it has to be, the angle has to be measured such that the plane in which you are going to measure the angle should be perpendicular to this plane and passing through this line. That is what is the angle we are interested in. Okay, because if we take any other plane, angular plane, then the angle is not going to be the same, and only the perpendicular plane to this passing through this line is going to give us the correct angle. Now, so we are interested in finding out this angle theta. However, if you look at this line is perpendicular and this vector is n bar vector. Therefore, if we find out the angle between n bar and vector b, then that will be this angle, and it is going to be complement of the required angle. Therefore, the angle between the line and plane is going to be sin theta, which is equal to b dot n upon absolute value of b into absolute value of n. This is what is going to be the value of sine of that angle, you have to take sine inverse of that, then you will get the angle between the line and plane. Okay, then after this what we are supposed to find out is perpendicular distance of a point from a line. So a point is given whose position vector is A, and a plane is given whose equation is r dot n is equal to q. Right? Now this is a statement of the problem, and we are supposed to find out if we drop perpendicular from here on this plane somewhere, it is perpendicular, then we are supposed to find out this distance. Okay, and that is A. Let us call this point as L, as it is called in my notes. Okay, so now this is a problem statement. Pause the video, try to find out your by your method what is going to be distance AL. If not, let us go through the proof. Now any point, okay, what is this N? N is the perpendicular vector to the plane, that is the normal vector. So if you want to find out perpendicular distance, what will be the vector of line AL? It is going to be N. Therefore, will we be able to write down the equation of line AL? Yes. Equation of line AL is going to be equal to R is equal to, it has to pass through A plus T times N. This is going to be the equation of perpendicular line. Now we are supposed to find out what is the foot of perpendicular. So we solve line simultaneously with the plane and get the value of T, that is the parameter. This equation means for different values of T, you keep getting different points on this line. If T is equal to 0, you get R is equal to A, that is what is our base point. So we need to find out what is the value of T, that is parameter, which is for point L on this plane. Therefore, we need to solve them simultaneously, and if R is put in this equation, we get A plus Tn bar dot n bar is equal to q. Now we have to solve this for T. Therefore, let us expand. A dot n bar plus T n bar is n square is equal to q. Therefore, T is equal to q minus A dot n bar upon n square. Now this is parameter, therefore this is supposed to be real number. So q is a real number, A dot n is a real number, and n square is of course a real number. Therefore for this parameter T, we will have point L with us. So what will be the position vector of L? R. We need to put this over here. R is equal to A plus q minus A dot n upon n square. That is the value of T, and T is a scalar multiple multiplied by n bar. Right? So this is what is the position vector of L, and now you are supposed to find out distance AL. Distance AL is vector. We want to find out length of vector AL. AL is L minus A. Therefore, vector AL is equal to A plus q minus A bar dot n bar upon n square times n bar minus A bar. So A bar gets cancelled. Therefore, we get AL is equal to only this quantity. And now we want to find out distance of AL. Therefore, absolute value of vector AL is equal to absolute value of this RHS, and therefore the final answer is going to be equal to absolute value of q minus A dot n bar upon n square into absolute value of n. Okay, now this n square you can write as absolute value of n into absolute value of n. So one absolute value of n gets cancelled, and therefore the equation that we need to remember is q minus a dot n upon n. This is what is the distance of a point from a plane. Okay, then comes distance of a point from plane is done. Now what will be the angle equations of planes bisecting the angle between the two given planes? Okay, so now I am erasing this, but you can pause, note it down, and then understand everything and go ahead. Okay, so angle between not angle, the equations of planes bisecting the angle between the two planes. So two planes are given, r dot n1 is equal to q1 and r dot n2 is equal to q2. These are the two planes which are given, and it is exactly as what we did in two-dimensional geometry. This is one plane, this is another plane, and we are supposed to find out the angle bisecting planes. So angle bisecting plane, one angle bisecting plane will be like this, another plane will be like this. So these are going to be angle bisecting planes. And now because we have found out the distance of a point from a plane, we will make use of that equation to find out the equations of angle bisecting planes. So suppose we take, basically if we take any point on angle bisecting plane P is any point, say R, its position vector is R. If we take any point, then what must happen? If this point is on angle bisecting plane, then its distance from both these planes must be same, and therefore we can directly write that R dot n1 minus q1 upon absolute value of n1, that is what is the distance from the first plane, should be equal to absolute value of r dot n2 minus q2 upon absolute value of n2. So practically this is what is going to be the equation of angle bisector. But if we, because whatever the quantity inside are all are real numbers, basically what we can do is we have compared the distance with distance, and now if we get rid of these absolute value signs, then we will have r dot n1 minus q1 upon n1 is equal to plus or minus r dot n2 minus q2 upon n2. So these are going to be the two planes which will be bisecting the angle between the given two planes. Now in 2D geometry also we leave the equation at this stage and don't simplify that. So if we simplify, we will get, I mean, r dot something, and there will be some constants etc. But that will be very complicated equation to remember. Therefore equations of planes bisecting the given two planes is finally written in this form only. Okay, then what we are going to do is finding out perpendicular distance of a point from a line. So if you go through this lecture, you will realize that one point, one line, one plane, two planes, angle between the line and plane, all the possible combinations are being conducted, and everything is possible to find out using just dot product. Okay, so the last thing is perpendicular distance of a point from a line. So you have been given a point A whose position vector is A, and there is a line L whose equation is R is equal to A bar plus T B bar. Sorry, A is already used, so B bar plus T C bar. Okay, and now we are supposed to find out the distance of this point from this line. Now deliberately I am not making this angle 90 degree here because they are in space, and now you can see that it still looks like 90 degree if you have that three-dimensional vision. Even if we are drawing on two-dimensional whiteboard, this is three-dimensional diagram. So we are supposed to find out this distance, and let us call foot of perpendicular, I don't have it, let us call it as again L. Okay, now any point on this line is represented by this, so L is going to be B plus TC for some specific value of T. Again, you try your level best to find out this distance, okay, else you watch this. So for suitable parameter T, point L is going to be fixed when perpendicular AL is going to be perpendicular to this. What is this, by the way? What is this vector? This vector is C. Vector is C. Whenever we say that this vector is C, you might be thinking, what is the length of that vector C? See, in this case, it is only the direction of the vector is important. Length, whatever length you want, you can take. You can take unit length, you can take length is equal to 2, etc. Length does not matter at this stage because this vector C is fixing the direction of that line. It is the support and the sense which is being fixed by C, and as far as so if we give any vector C whose length is 1, 2, 5, whatever, does not matter. We are interested in the direction. Therefore, every time when I say that this vector is C, so the length does not matter, it is the only direction which matters, the support and sense. So now we are supposed to find out the value of T, for which we get this point L, so that AL is perpendicular to the line. So we say that this is B plus TC, or maybe T1C is a. So what will be the equation? What will be the vector AL? Vector AL is going to be equal to B plus T1C minus A. This is going to be vector AL, and now vector AL must be perpendicular to C. So if we take dot product, AL dot C should be equal to 0. So B bar plus T1 C bar minus A bar dot C bar is equal to 0. This should give us value of T1. So if we expand, we get B dot C plus T1 C square minus A dot C is equal to 0. Therefore T1 is equal to B minus A dot C. So that side we take it A minus B dot C upon C square. So this is the parameter of L. And now we are supposed to find out the distance. So distance AL, absolute value of AL is going to be equal to absolute. Now we have to write this over here. So our point L is going to be, our point L is absolute value of B plus A minus B dot C upon C square, that is value of T1, into, this is the parameter, into C, that is what is coordinate of L, minus A, absolute value of A. So for all practical purposes, this is what is the distance of a point from a line. Now you can simplify a bit, but finally it is going to be like that only. Okay, so that is what is the distance of a point from a line. Now this is completely theory, no numbers. You will be given numbers and you are asked to find out what is the distance of a point from a line, point from a plane, etc. There are plenty of problems in the books. Now slowly you should go through, engage and figure out which particular problems you can solve. Now this is lecture number I think 8. So Up to scalar products we have done. Now next lectures we will define a vector product and then some advanced product like scalar triple product or vector triple product, etc. Thank you.